Okay, artificial intelligence. Now, one of the founding fathers of this artificial intelligence that you can see on this picture over here, he's American scientist John McCarthy. In 1955, of course, he published a document coining this particular word, artificial intelligence. Now it is making a lot of waves among our followers. Of course, you have something called general artificial intelligence, which is some kind of a robot who can do everything according to the films. But reality, it is not the same. In my personal opinion, it is not likely to appear in real world anytime soon. And of course, what we are seeing is the narrow artificial intelligence in the day-to-day life of ours. Now, this is what you see around us. If you look at the Tesla, the autonomous driving car, that is collecting the data. Now, this data, he will collect it, process it, analyze it, and he will improve his driving. So this is a machine learning how to do things right. Of course, you have to have proper algorithms prepared for that. This is what I'm going to explain to you, how I use these things in my construction and design development practice. Of course, it is not a program thing, because that is, you give the data, you provide proper cleaning process, and then get things represented in a fair manner to get the predictions done based on the patterns. Now, for example, if you are watching Netflix or some other channel, they will collect your data. They will follow you. They will know what kind of films that you want to see. So based on that, he analyzes your data and suggests you watch this movie also. You watch this movie also. This is our AI algorithms that they are working here. Sometimes maybe your phone is hearing you and he's collecting data, and then one fine day you find your Facebook, they are putting a lot of advertisement about what you are interested. So this is artificial intelligence, right? Now, how do I use that in my construction practice is something very similar, but I want to give you an idea of what is algorithm. And I am going to give you that idea through this simple linear regression example. Now, you see, this particular simple linear regression is something that we have to. Something's wrong. Let me get back to that as well. Yeah, simple linear regression. Now, remember, although it is an algorithm created by artificial intelligence, still it has an error. Now, what is happening is that you are minimizing that error. So don't think that what you get from artificial intelligence free of errors. No, error is there, but it is minimized. How do I do that? Now, for example, they calculate the sum of squares of errors and try to minimize that. Now, by doing that, you use the partial differentiation to work out the minimum value for that error. Now, the core idea is to obtain line that best fit to the data using linear regression. Now, look at this. Now, the best fit line is the one that has total prediction error for all data points, the smallest. Not only one, or whatever the data that you collected, you work out your line in such a way that error to each and every data point is minimized as a sum of squares. So this is the point that you have to understand. Now, total prediction error of the line has been minimized to the extent possible. Now, I'm just taking a very simple example of variables x and y. So dependent variable is y and your variable is x. And of course, you know the y equals mx plus c equation, the same thing, y equals beta naught plus beta 1 x plus error. So this error is always to be minimized. Now, for example, these are the data points. Now, you can draw lines across these data points as much as you want, but that is not the best fit line. Best fit line is something like this. Once you draw that, you have an error which is going to be minimized through this partial differentiation. When you do the partial differentiation, dabba over dabba beta 1 equals 0 will solve the beta 1 value like this, and it will give you an equation. And similarly, dabba SSC over dabba beta 0 will solve beta 0 like this. Now, once I get these beta values, I can easily get once I get this particular slope, that is beta naught, beta 1, and the coordinate beta naught, I know this is the straight lines. Once I know the best fit line, then any x value, I can find the y value. So this is the simple linear regression algorithm. Now, these algorithms are here. These are the kind of equations by which that you work out things. Now, this is the error. Now, for this data point, this much error is there always, but you have minimized these squares of errors in this through this algorithm. Now, for that, you must find out whether your data is, how good your data is. Now, for that, there are three equations by which that you can calculate variance, covariance, and correlation. Now, this correlation is very important. Correlation will give you a value between +1 and -1, giving relationship between two numerical variables. Now, this is not only for two numerical variables. You can have any number of variables. Now, if you have more than, let us say that you have 3 variables, then your graph will be not a line, but a plane. So something like that. So this correlation value is calculated by this equation. Now, if your correlation is perfect, you will have something like this. If your correlation is 0.8, you have a highly positive correlation. If your correlation value is 0.3, you have a low positive correlation. Anything more than 0.3 is okay for you to do this particular regression analysis. And of course, no correlation situations are also there. And that situations, you have to do other type of regression analysis. I will show you a couple of things at a later slide. Of course, highly negative and negative correlation is something like this. Now, I'm just showing you a very simple example how to use the linear regression line algorithm to find, based on the age, the glucose or the sugar value, having collected the data. All what you have to do is to see that equation beta 1 and beta naught. For that, I need the average x and average y. Now, x is the age, y is the glucose level. Now, for that, you can easily find the x bar, that is average. What you do, you add 43, 21, 25, 42, 57, 59, and divide by 6. Then you get 41.17. Similarly, you get the y average, adding all these things, divide by 6, you get 81. The moment you get that figure, you can work out these values. I have worked it out this much, x squared and xi minus x bar is this much, yi minus y bar is this much. And then based on that, I have calculated the beta 1 as 0.39. And then beta 0 is 65.14. Moment I know the slope and the coordinate, the beta 0, I can plot my line. So moment I plot the line, that is the estimated model line that gives the minimum RSS value for the given data set. That is y hat equals b hat plus beta hat x. Now here, what is happening is that, now if I say that Nihal's age is 55, I want to find out what would be possible glucose value for him. Now for that, I apply this equation here. 65.14 is the beta 0, 0.39 is the slope, and age is 55. Now I get 86. Now this is a prediction from this particular set of data. There is no relationship at all, but you study the pattern, you use the linear regression and get this figure like this. Now, this is how artificial intelligent algorithms will work. Now, of course, my correlation value is 0.385. It is more than 3, so it is reasonable for you to use this type of algorithms to do this type of calculations to get the predictions. The idea here is you collect the data, you analyze the data, and then you predict the data. Now, after you predicting, you can actually check it. What is the actual sugar level? And based on that, you can find what is the accuracy of this particular model. So if the model is giving an accuracy of 80 to 85%, that is good enough. So from that, you can make all these type of calculations where there is no relationship, only you have data. So you ask the machine to do the calculation. Of course, I am manually showing it here, but this is what the machine is doing. So machine learns how to do his calculation on his own based on the equations that you are giving. Now here, these are the kind of algorithms that you should understand as an engineer. This is linear regression. This is logistic regression. I use this logistic regression to predict the weather. For example, if it is raining, I cannot do the construction work. Now I collect all the data that is for past so many months, and based on that, I can say whether it will rain or not. So that type of analysis can be done with using this logistic regression AI algorithms. Now, k-mean clusters is another one that we normally use. Decision trees I always use because you see the problem is engineers take decisions based on the common sense. No, you must take decisions based on the data. And then you collect the data, you analyze the data, you see what is happening. Based on that, you give the predictions. And then you can be guided by your decision. Otherwise, you will be always wrong. I will show you one more example, how to select a crane. Random forest also another algorithm that we can use. And then, of course, time series forecasting, we always use for this project controls and progress analysis. Right. And let me show you one example here. Now, this is an example where you should decide whether I use a small crane or a large crane. The subject is like this. Any crane has a certain probability for the long term delays, medium term delays, and short term delays. Now, if you take an event, if you have a probability, all the events, long, medium, and short, if you add all three, it should be 1. Now, you can see the small crane probability is 0.3, 0.4, 0.3, and the delay of days is 12 days, 7 days, and 4 days. Now, this type of information are always available with us because we are daily using cranes. We keep records of these things, and if such delay happens, we keep these records. Now, the point is that small crane rental cost is $12,000 because it costs less and it works slow also. Now, large crane will cost me $18,000. Now, if somebody is using common sense, he will go for the crane which is costing only 12,000 because he thinks that he made the right choice. No, not only the price. You see, if you delay your work, there will be liquidity damages. Now, for example, here I'm saying if I delay 1 day, I have to pay $6,000 per day. Now, that also should be taken into consideration when you are doing your evaluation to decide whether to use small crane or the large crane. And again, when you do the analysis of your baseline program, you will find in a particular activity that where we are going to use this small crane or the large crane, there is a 40% chance the activity becoming critical. So you have to consider that also. And then you have to find out what is the expected monetary value of selecting either small crane or the large crane. If the value is less, expected monetary value is less, then you can select this thing. Let us see how I decide on that based on this particular. Now, you have to first check whether it is in the critical path or not. Now, if it is in the critical path, my 0.4 is the probability of becoming that activity critical. So if it is 0.4, then you have a chance of delay. If it is a critical activity, if it is delayed, your project will be delayed. So this is the theory of schedule analysis. Now, what the table here says, if it is not critical, that is the probability of that being not critical is 0.6. Now, to calculate the expected monetary value, you must multiply the probability by the cost of recovering from that particular risk. Now, for example, there is a probability of 30% of this activity being delayed by 12 days. There is a probability of 40% of this activity being delayed by 7 days. There is a probability of 30% of this activity being delayed by 4 days. Now, if there is a delay, then you have a cost to that. Now, you have to evaluate that cost, how much. And now, how do I do that? You have the probability of it being becoming a critical activity is 0.4. And then if it is delaying 12 days, the probability is 0.3. So I told you expected monetary value is the probability multiplied by the cost that involved in this particular activity. Now, what is the cost? I have to hire the crane. If it is a small crane, $12,000 I have to spend. And if I delay 12 days, I must spend 12 into $6,000, about $10,080 for that particular path. Now, this is what I want you to understand. That is how you calculate each and every possibility, how much the expected monetary value. Now, if you calculate all these expected monetary values like this, and then you can really get your, oh my gosh. I have an issue. Let me do it again and see. Right. And similarly, you can calculate what is the expected monetary value that you incur if you go with the large crane as well. Now, when you calculate all that, you will find if I go with the small crane, my expected value is 30,240 US dollars. Whereas if I use the large crane, my expected monetary value is 200,000 US dollars. Now you can see my expected monetary value is less in the large crane. Now I should take the decision to use the large crane, not the small crane. This is what I am trying to tell you. You must use your data and use your algorithms to do your calculations and then develop your model in such a way that you can take decisions based on data. Now here, based on data, I should go with the large crane. So this is what the advantage of you having AI algorithms working with you in your decision making. Now this is called decision tree analysis, which I showed you before. And based on that, the expected monetary value is the lowest when you use the large crane. And this is an example of how you can use decision tree calculation, evaluate expected monetary value, and make your choice. No AI involved here. But you can do the same thing when you are developing your model. For example, I was developing this particular Maldives International Airport project management model. And one fine day, I found the model is telling me, remove the tower crane, remove the tower crane. Then I checked why he's asking me to remove the tower crane. I have not completed the work in that particular area, because when I was giving the instructions to develop the model, I have given all the hiring data also and the actual operation data as well. So he calculated and found if I hire a mobile crane, I can do the same job. Because of that, he was suggesting me to remove the tower crane. So this type of situation, you cannot leave it to the computer, because you must always run your AI model or the digital twin, whatever it is, on the pilot mode, autopilot mode. You must always check what is he trying to tell you. And based on that, you must take decisions. You cannot leave it to the machine, everything. Now, data science is also important in project management. Now, you must first get your data collected, and you must investigate to understand the basics of this data, to understand what is going on. Then you try to take this data and try to understand what is happening. And based on the patterns that data is happening, you give the predictions. Oh, I'm not going to finish this project in 2025 December. So that type of predictions you can do if you have the data. Now, after predicting, you must try to, you understand the problem, so you must try to optimize your operation in such a way that data give a better interpretation of your targets, using data to choose what is the best choice of action that you can take. Now, because you cannot, now if your model or your algorithm is saying that your cost performance index is certain value, you should immediately understand, oh, you are going to delay this project. So you must find what action that you can take into consideration to avoid these delays. Now, in data science pipeline, in engineering or the project management, you start gathering data. That data is raw data. Then you must start cleaning the data, because I'll show you what the cleaning is. After cleaning only that, you must visualize this data. And then based on the clean data only that, you must do your modeling. And then you can sort of interpret the data, what it is. Now, if your initial data set is bad, you have a big problem. That is, you make your incorrect analysis. And whatever the insights that you are deriving from your data will be invalid. And of course, invalid insights will lead you to a wrong decisions. Now, if the wrong decision is wrong, your outcome will be very poor. So you got to understand these principles to apply this data analytics as well. Right. Now, common problems in collecting data, missing values. Sometimes people miss entering certain data. So that time you should be clever enough to find an intelligent way to fill this missing data. And then you have duplicated values. Same data, it will be repeated by somebody else, again, the same thing. Now, these things, you cannot just remove the data. You must consult the concerned doctor or whoever the person who provided this data to understand why he is giving this data and do the cleaning. And similarly, outliers. Sometimes you get certain figures that are not believable. Now, for example, here, the age, height, and the weight is there. 150 is an outlier. So that type of things, when happens, you should know how to correct this data. So that is what I was talking to you. You cannot just take the data and do the analysis and get the results. You will be wrong. So again, the database also, there is a certain format that you have to prepare your database with the headers and the fields. So that type of arrangement you must make it first before you do your data analytics. Now, automating repetitive tasks. Now, this is what I'm showing you, the Primavera P6 professional program by which we do the schedule analysis. We do our own, what do you call this, baseline program. And when you try to start your project, before starting the project, you decide what is the baseline program that you are going to follow. And after deciding and getting approval or the consent to that, then you monitor your actual work against this baseline. Now, when you do this type of activity, you will have to do your all updating. There are about 20,000, 30,000 activities in a large project like Maldives International Airport. Now, that time, each data date that you update and change the data date after 1 month, again you update. Like that, you have several updates of that particular thing. Now, here, what I'm trying to do, this Primavera P6 is an excellent program for the planning. It is not project management, it is only planning. Now, when you get this data, you can connect this data through no-code, low-code applications to analyze the data. Now, I use Power BI. Now, Power BI is a no-code, low-code application, and it's a platform. And by that, I can clean the data. I can analyze the data, and I can visualize the data, and I can predict the data and develop a dashboard by which I can understand what is going on. Now, for example, now here, I'm showing you one dashboard where I have made my update on December 11th cost data. Based on this December 11, only green light I see on the 2 complete performance index. So it was intelligent enough to tell me, maintain this trend, you can complete remaining work within budget. So it's a good news, but I have 3 red marks. He says my cost performance index is not good. My variance at completion is not good. So he is giving me the guidance. So based on that, I adjust myself in next month. Now look at the next month. Next month, I have this red now is amber, so that I'm improving it. Now my cost performance index is 0.87. I want to make it 1, then only I'll be all right. So he's telling me, maintain this record trend, you can complete remaining work within budget. So still I'm within my parameters. Now here, what I see here is the update 7. Now this is where they do the data analytics and give me the predictions. He says, man, you are all right. Your cost performance index is all okay. Cumulative cost variance is okay. Your variance at completion is okay, but your TCPI is not good. What is he saying? Unless you improve current rate of progress, it rather unlikely you complete remaining work within the remaining budget. So this is the artificial intelligence coming into the play. Now he analyzed my data, and he is telling me, man, you are all right, but your TCPI must be improved. Now this type of thing I cannot do my own. This must be some repetitive process. Of course, project management is always a repetitive process. Now that you leave it to the computer or the machine, and then he will give you the predictions. Based on that, you look into other aspects of it and try to improve it. I hope this gave you a good understanding of how artificial intelligence and the data analytics I use in construction and design development. Thank you so much.
Thank you very much, Engineer Nihal Premachandra. I would like to open the floor for any questions that you all might have with regard to today's session. Anything regarding the enrollment process or application process for the MSc programs. Anything in particular related to Engineer Nihal's presentation. You all can, I think, unmute yourselves and ask the question, or you can drop the question on the chat box now. We have about 5 to 10 minutes, so you all can unmute yourselves and ask your question or drop it on the chat box now. We have a question about when is the next intake for MSc. The current intake would be July. We'll be starting on the 19th of July, and y'all can still join, y'all can still apply, but I would advise you to apply at least by tomorrow noon, if possible, because you will need to do the aptitude test as well as the interview. Aptitude test will be on the 13th of July, and the interview will be on the 15th of July. So please make sure that you submit your applications by 12 noon tomorrow so that you can join this intake itself. Sankaja, I think that was the question. If not this intake, it would be January next year. That is what is planned so far. Any other questions? If we don't have any other questions, we can wrap up the session for tonight. Are there any questions directed to you in the chat box, if at all?
No questions, it seems to me.
Any final words, Engineer Premachandra, that you would like to mention to the participants before we close for the night?
Yes, guys, you should start this digitalization and try to understand the future developments, especially now ChatGPT is coming. Of course, I'm doing all the answers to my contractual questions using ChatGPT now, because if you know the prompt engineering right, you can really do amazing work, and you would like as if you are of course I have 38 years of experience. Because of that, I dig everything. But even if you don't have the experience, still you can use this digitalization world to your advantage. So better that you learn the subject and improve your skills. You can always have your opportunities in Sri Lanka as well as abroad. Thank you.
Thank you very much. I would like to, we can close the session now. A very big thank you to the participants for joining today, and a very special thank you to you, sir, Engineer
Thank
Nihal
you.
Premachandra, for the informative session on the use of digital twins, data analytics, and artificial intelligence in design, development, and construction. Thank you very much, and we wish you a good night.
Thank you. Good night.